Let's look at the first tuning approach, which is closed loop PID tuning. So we are going to look at continuous cycling method introduced by Ziegler and Nichols in 1942, which has been introduced in the paper titled Introduce the Continuous Cycling Method for Controller Tuning. This tuning approach is based on try and error procedure as follows. In the first step, after the process has reached steady state, or at least approximately steady state, the next step is to eliminate the integral and derivative function. So to eliminate the integral and derivative function, we can simply adjust the value by setting, for example, tau d, which represent the derivative control, to 0. So if we look at the previous equation, where this is the PID equation with proportional term, integral term, and derivative term. So we can eliminate the derivative by taking tau d equivalent to 0. So the whole term here will be 0. So next, to eliminate the integral term, what we can do is to not reduce tau I to 0, but we should increase the value of tau I instead. So we should increase to infinity so that we can make this value to 0. But in practical process control, the value of tau I is impossible to increase to infinity. So we can at least increase the value of tau I to the maximum value possible. In step 2, we set Kc equal to a small value, for example 0.5, and place the controller in automatic mode or in a closed loop mode. In step 3, introduce a small momentary set point change so that the control variable or PV move away from the set point, and then gradually increase the controller gain in small increment until the continuous cycling occurs. The term continuous cycling refers to a sustained oscillation with a constant amplitude. This response is showing the sustained oscillation example. So we have this response is the process variable, the response oscillating, and we can see the magnitude, which means the peak to peak value is the same, or valley to valley is the same. And then we can see that the period of time between valley to valley or peak to peak is the same. So this condition is called sustained oscillation. So the numerical value of Kc, just now we increased the Kc gradually. So once we achieve the continuous cycling, the numerical values of Kc that produces the continuous cycling is called the ultimate gain, or we can label it as Kcu. The period of the corresponding sustained oscillation which we can measure between peak to peak or valley to valley, is referred to as the ultimate period, PU. So from this step, we managed to get what is the value of KCU and what is the value of PU.